What if the entire universe we know exists inside a black hole? Could this explain why our universe began with the Big Bang? Why are the physical constants so perfectly fine-tuned for life? This isn't science fiction. This is a serious physics hypothesis called black hole cosmology. In this video, we'll explore why scientists think this is possible, what evidence they see, and what it means for our future. Let's start with the basics. Black holes and their physics. A black hole is a region of space where gravity is so intense that even light cannot escape. They form when massive stars collapse at the end of their lives. All matter compresses into a point of infinite density, a singularity. The boundary beyond which there is no return is called the event horizon. Black holes come in different sizes. Stellar black holes have masses several times greater than the Sun. Supermassive black holes containing millions of solar masses hide at the centers of galaxies. Sagittarius A, the black hole at the center of our Milky Way, weighs 4 million solar masses. But here's where it gets interesting. When Einstein described gravity, he showed that massive objects curve space-time around themselves. A black hole is the extreme manifestation of this effect. Space-time inside the event horizon curves so severely that strange things become possible. According to the mathematics of rotating black holes, the Kerr metric, paths through such a hole don't necessarily lead to the singularity. They could lead to entirely different regions of space-time. Theoretically, they might lead to white holes, to other universes, or to combinations thereof. This observation opened the door to a revolutionary idea. What if our Big Bang isn't the beginning of everything, but rather the birth of our universe inside a black hole from a parent universe? The Big Bang and entropy. The Big Bang theory states that 8 billion years ago, the entire universe was compressed into a single point, infinitely hot and infinitely dense. It's supported by multiple observations: cosmic microwave background radiation, abundance of light elements, and the expansion of the universe. But the theory has a serious problem: initial conditions. At the moment of the Big Bang, the universe had extraordinarily low entropy, a highly ordered state. Yet the second law of thermodynamics says entropy always increases. Why did the universe start in such an improbable state? This is where black holes become key. Stephen Hawking discovered that black holes have entropy, proportional to the area of their event horizon. This means a newly born black hole has low entropy. If our universe arose as a side effect of a black hole forming in another universe, then the low entropy of our Big Bang simply reflects the low entropy of that black hole. As our universe develops, entropy increases, exactly as thermodynamics requires. This solves one of cosmology's deepest mysteries. There's another problem: fine-tuning. The physical constants of our universe, matter density, gravity strength, the difference between matter and antimatter, seem perfectly calibrated for life. If they were even slightly different, stars and galaxies would never form. Why is the universe so improbably perfect for life? It seems like an incredible coincidence. Smolin's hypothesis. Black hole cosmology. In 1991, physicist Lee Smolin proposed an answer: cosmic evolution. Smolin suggested that black holes aren't the end of stellar life, but the birth of new universes. When a star collapses into a black hole, the singularity, from the perspective of physics inside it, is the Big Bang of a new universe. This new universe expands inside the black hole, forming stars, galaxies, and new black holes. Those, in turn, give birth to new universes, a family tree of universes. But Smolin went further. He proposed that the physical constants of a daughter universe differ slightly from those of the parent universe. Something like mutation occurs. If universes can reproduce, then through a process resembling natural selection, universes that create many black holes will have more offspring. And universes that create many black holes must have very specific physical properties, roughly the same as ours. We don't inhabit a randomly fine-tuned universe. We inhabit a descendant of universes that were good at making black holes. Our universe is the natural result of cosmic evolution. There's an even stranger variation, the bootstrap universe. What if the parent and daughter universes have identical constants? What if it's the same universe at different levels? Then the universe creates itself. It exists necessarily, not by chance. This answers a philosophical question. Why is there something rather than nothing? Evidence and testing. If we live inside a black hole, should we see evidence of it? The answer, no. The event horizon is so far away that it could never be detected. If we lived inside a supermassive black hole the size of a galaxy, we wouldn't notice anything. But there are indirect signs. If our universe was born in a black hole, it might leave imprints on cosmic microwave background radiation, the universe's ancient light. Astronomers search for these imprints, but nothing definitive has been found yet. The problem is that this hypothesis is very difficult to test. Many physicists criticize it precisely for this. It doesn't make clear predictions that observations can refute. On the other hand, the hypothesis solves several fundamental problems simultaneously. Explains the low entropy of the Big Bang. Explains the fine-tuning of physical constants. Explains why anything exists at all. Connects quantum mechanics with cosmology. Some alternative explanations exist. For example, multiverses from quantum mechanics or the anthropic principle. But none solves all the problems as elegantly. Physical and philosophical implications. If we live inside a black hole, it fundamentally changes our understanding of reality. Physically, it means the universe has a boundary, the event horizon. We could never escape beyond this boundary no matter how far we travel. It's the maximum limit of human expansion. But the deeper meaning is philosophical. If the universe creates itself through black holes, then there's no first cause, no creator outside the universe. The universe simply is. Its existence is logically necessary, not accidental. This turns traditional religious and philosophical questions upside down. We're not hapless accidents in an indifferent universe. We're part of a cosmic system that reproduces and evolves. Perhaps consciousness and life aren't byproducts but a natural part of the universe's functioning. The hypothesis also suggests that all universes are connected in one vast ecosystem. Somewhere exist parent universes that created ours. Perhaps we create daughter universes through our black holes. Criticism and problems. Not all physicists admire this hypothesis. The main criticism: it makes no testable predictions. In science, a hypothesis is considered scientific only if it can be refuted. Black hole cosmology seems irrefutable. We cannot prove or disprove whether we live inside a black hole. A second problem: the hypothesis doesn't explain why the parent universe exists. It merely pushes the problem up one level. A third problem: mathematical details aren't worked out. How exactly does a quantum process in a black hole become the Big Bang? This remains an open question. Nevertheless, the hypothesis attracts attention because it's elegant and unifies several areas of physics: general relativity, quantum mechanics, thermodynamics, and cosmology. Alternative explanations exist. For instance, the many worlds interpretation of quantum mechanics proposes that all possible universes exist. We simply inhabit one that allows us to exist. This explains fine-tuning, but no alternative explanation solves all the problems simultaneously. Mershastur, new developments in the future. Recent developments in quantum gravity offer new hope for the hypothesis. Loop quantum gravity suggests singularities don't exist. Instead, a quantum bounce occurs, a transition from a contracting universe to an expanding one. If true, the Big Bang could be such a bounce happening inside a black hole. String theory unveiled the holographic principle, the idea that a three-dimensional universe could be a projection of information from a two-dimensional surface. This may be connected to black holes and their event horizons. Observational astronomy helps too. The detection of gravitational waves confirm that black holes are real and far more common than we thought. Direct observation of the event horizon of the black hole in galaxy M87 opened a new window into black hole physics. In coming decades, the James Webb Space Telescope and new gravitational detectors might reveal new information. Perhaps we'll find imprints in cosmic radiation indicating we live inside a black hole. What it means for us. Does it matter practically whether we live inside a black hole or not? No. Gravity works the same. Stars shine the same. Life develops the same way. But philosophically, it matters. It means we're not a random phenomenon in an indifferent universe. We're part of a cosmic mechanism that reproduces and evolves. Perhaps life and consciousness aren't exceptions but rules. It means the universe is a living system, not biologically, but in the sense of self-reproducing and self-organizing. Most importantly, it reminds us how little we know. The deepest questions of physics. Why does the universe exist? Why is it structured the way it is? May have answers we can't even imagine now. The cosmos is far stranger and more wonderful than everyday experience suggests. Do we live inside a black hole? We don't know, but it's possible. The hypothesis solves fundamental problems in our understanding of the cosmos. It's taken seriously by some of the world's best physicists, but it remains unproven, and that's fine. Science advances through bold ideas that we test, analyze, and either accept or reject. What we know for certain, the universe is full of wonders. Galaxies contain billions of stars. Black holes curve space-time. Consciousness emerged from matter, and we're capable of understanding all of it. If this video intrigued you, subscribe to the channel. We have many more videos coming about space, black holes, and the nature of reality. Thank you for watching. Keep looking up.